Now I scratched this one out because I just got in a roll and I just started doing all the odds, and then I would wait, I didn't give them all the odds. That's a lot of work. Oh, yeah. So I reduced a lot of what you need. I tried to pick the ones that I found important. And then I went ahead and gave you the equations down here for the graphs, which I'll go over that a little more thoroughly when we get there on the homework. Okay. So sine and cosine graphs, sine and cosines, that they're related. They're very similar to each other. Again, the cosine is just a shift of the sine. So hopefully this first part wasn't too demanding. And again, let me know if there's a specific one you want me to go over with you, because I'm probably gonna do a good bit of summary. So basically, if you want to find the period, just put the domain expression equal to 2 pi. Okay, so just put the domain expression equal to 2 pi. And the amplitude is a measure of a distance above or below. So if it's negative, that doesn't mean you have a negative amplitude. That just means instead of starting above, you're going to start below. But the amplitude is an absolute value. It's a distance, right? If you put negative 1/2, it's not that big a deal. But technically, the amplitude is a distance. It's the negative just means you start below instead of above. All right. Again, so here when you put the angle expression equals 0, the negative in the angle expression, that just tells you rotate in the clockwise direction. If you want the period, you just want the positive number. You just want the width of the period, which is a distance. The negative in the angle expression, that just means instead of rotating counterclockwise, you rotate clockwise. You go in the negative direction. When you graph, it should go to the right. So the equation, you don't need the negative. You're just trying to find the width of the period. Okay, and then, the domains of these is the range, it's just in between the top and bottom, and the domain is all real numbers. So any decimal value can be used for radians. And again, don't forget the width. So notice I put here, and it became gray. It was red, but when I took out the color, which saves on file size, I wanted to visually show you that above the x-axis by 4 and below the x-axis by 4. That's really what the 4 means, right? And then period, quarters. After you do these for a while, you might have other ways to break this down. But anyway, so here, again, drawing the unit circle, same thing here. Now, when you have the vertical displacement, if you're able to interpret this, you could just go ahead and draw, okay, we're center at 3, and since it's the amplitude's 2, we're going to be above 2 by 2, so 2 plus 3, and below by 2, so 3 minus 2. You could think of it that way, and that's really what I'm doing here in the unit circle, right? Since this is the sign, 0, 1, 0, negative 1, you could just go 2 times 0, 2 times 1, 2 times negative 1, and then plus the 3. So that's really, for me, having a visual aid helps me focus, So that's what I use that for. Okay. And one of the reasons we have the pi as part of the domain expression is that enables us to have non-pi units on the x-axis. And so that's part of the reason why that happens. And again, this is the cosine. So normally it would be 1, 0, negative 1, 0, right? And so you could think 5 times 1 minus 3, 5 times 0 minus 3, 5 times negative 1 minus 3, 5 times 0 minus 3. So that's how I got these 4 numbers. And for me, that just makes it visual. But, if you want to drop down to the y equals negative 3, make that the center. The amplitude's 5, so you're going to be 5 above the negative 3 and 5 below the negative 3. If that works for you, that's okay. All right. Now, when you have a negative period, just go in the negative direction. Again, this is one of the reasons why the unit circle is helpful. Right? So it's either 5/3 or negative 5/3 since there's no vertical displacement. Okay, so here we're going to start below. We'll go below first instead of going up, and then Now, when you have the intervals that are a little bit less intuitive, the quarters is very helpful. So again, put the domain expression. I didn't put a negative here because we just want the width. So I did that, multiplied the reciprocal, and so 3. So 1 period is 3, so 2 periods gets to 6. Each quarter of a cycle is divided the period by 4, so 3/4, 6/4, 9/4, 12/4. And so that can be helpful when you have intervals that are not whole numbers. Okay, same thing here, negative frequency. Now with the cosine, since the cosine is an even function, which means you change the sign of the input doesn't affect. And that's because if you go in the negative direction with the cosine, you still go to 0 because the cosine is still positive and you go in the negative direction. So there's no difference with the negative period with a cosine, but there is a sine. Because with the sine, if you go in the positive direction, you hit a positive. But if you go in the negative direction, you're going to hit a negative. All right. So anyway, get the period, and then I divided the period by 4, which means multiply 1/4. And so now we have the quarter intervals. They're each 1/3, and then you can go ahead and create exact values for the x-axis intervals. Okay, and so then here's the way to get the equations. So first I got the period amplitude, then I solved the angle expression. So the period was 8, so 8 times k, what's that going to be to get 2 pi? Right, so that's what I'm showing you there. So with this one, okay, so it has a center of y equals 0, so there's no vertical displacement. It's starting above the center, so this is a cosine. And the width of one cycle went from 0 to 8. Right? 65, it's got the center y equals 0. It's starting below, so that means we're going to use a negative amplitude. And the width of one cycle looks like it goes from 0 to 4 pi. So that's why I went ahead, okay, 4 pi times what would equal 2 pi? So you're basically doing, instead of finding the period, you're doing the same thing, but solving for k. All right, so then that means that's the number, that's the frequency. Remember, the frequency means that's the portion of the graph in a 2 pi interval. Right? So notice in 2 pi, from 0 to 2 pi, we got half of the cosine. You could think of it that way too. If you want to think of it that way, that'll enable you to get 1/2 pretty quickly. And again, we're going to make the amplitude negative and not mess with the period negative, because that's easier. And remember, with the cosine, if you tried to get the -3 by putting the negative in, it's an even function. It won't be sufficient to create this graph. So that's why it's better to do the negative amplitude if you start below, or with the sign if you go down first instead of up. All right, so again, y equals 0, center. Looks like we're going above by 3/4, down by 3/4, so that means 3/4 is the amplitude. We're starting on the center line, so this is the sine, and it looks like the width of one period is 1. Okay, so that's what I wrote right here. And then so 1 times k would equal 2 pi. That gets us the frequency. Okay, and then the last two, 69 and 71. Okay, only 71 had a vertical displacement. Right. 69, center line is still y equals 0. Amplitude is 1. We're starting by going down first, so we're going to use a negative amplitude. The width of one cycle is 4 pi over 3. Okay, so that's what I'm doing here. And then again, I put a negative in front of the sign. Okay, and then for this one, looks like we had a center line go up 1, so y equals 1. So we're going to plus 1. And since the center line is 1, that means we're starting below. So this is the cosine. And we're going to use a negative period because we're starting below instead of starting above the center of y equals 1. All right, so what's the width of one cycle? It looks like we went from 0 to 3/2. Okay, so that's why I'm doing what I did here. Okie dokie.